Okay, good morning everyone. So let us begin our today's class. So today we will discuss few things about mass and weight, and then we will discuss about uh, the free fall of an object. So let us start with the mass and weight. So we need to understand what is mass and what is weight and how they are different from each other. Okay, so first thing is mass. So what is mass? You may have read it in already your earlier classes that mass is nothing but the quantity of matter which an object has in it, right? So quantity of matter, it is composed of atoms. So it depends upon how much or how many number of atoms an object has. This together make the total mass of the object. So in simple way, quantity of matter in any object, it is called as the mass of that object. So mass is the quantity of amount of matter which an object has, and it is measured in kilogram. For example, if you go to a shop and ask for 1 kilogram flour or 2 kilogram of fruits of any kind, apple or banana, sorry, not banana, but any other kind, whatever you ask for in mass, right? 1 kilogram, half kg, 250 grams or so. That means you are asking for a particular mass of that substance, right? So you are asking for the mass in kilograms or grams or any other such units, right? So the mass is the quantity of matter which an object has, and it is measured in kilogram in SI system, and in grams which is represented by small g in CGS units, right? System of units. So this is the way we understand the mass of an object. So mass of any object is nothing but the quantity of matter of the quantity of matter or substance in any object. Aluminium is an object of aluminium has the matter aluminium, or we can say substance aluminium in it of particular mass in kilogram or grams. And similarly, utensils just like of made up of steel, or we can say copper, they have definite amount of that material or substance or matter in terms of kilograms. So that means we are talking about the mass. So mass is the quantity of particular matter of which an object is made of. And on the other hand, what is weight? Weight is the gravitational pull or force of the earth on the object. If we are talking about on the earth, gravitational force of the earth, so weight is nothing but the gravitational pull of the earth, gravitational pull or gravitational force of the earth on that object. And of course it depends upon that mass of the individual object also, because Newton's law of gravitation says that the gravitational force between any two objects, it depends upon the masses of the two objects. It depends directly on the masses of the two objects. So that means an object having more mass will have more gravitational pull towards the earth due to the gravitational force of the earth. You can understand it that way. So weight of any object, it depends upon the mass, but it is not the mass. Most of the time students make such kind of mistakes. They take the mass to be the weight and weight to be the mass, right? So that is not correct. So mass is different. It is the quantity of matter measured in kilograms or grams, whereas weight is the force. It is the gravitational pull or force of the earth on the object. And because it is a force, so it is measured in Newton, right? Which is written as either capital N, or in small it is written as Newton as a whole, right? So this is the difference between mass and weight. Mass is the quantity of matter, whereas weight is the force, gravitational force of the earth on the object. And similarly, we can talk about the weight of the person or any object on the surface of moon or on the surface of the Mars. That will be different. That will depend upon that. That will depend upon the mass and that radius of that, we can say, planet or astronomical object. Okay, so this is the weight. So weight of any object, we have the formula to calculate the weight of any object, just as I have given the assignment to you last time. It is given by weight is equal to W is equal to M into G, where M is the mass of the object. This is the representation of mass, right? So mass into G, where G, this small g, it is nothing but the acceleration due to gravity or gravitational force of the earth, because gravitational force of earth is acting on the object. So this gravitational force is pulling each and every object towards itself. So this each and every object faces the acceleration towards the gravitational force of the earth. So that's why this small g, it is the symbol for the acceleration caused by the gravitational force of the earth, right? So there, that's why it is called as acceleration due to gravity or gravitational force. Okay, so this is the formula to calculate the weight of any object. You can calculate your own weight by using this formula. You have to just put the value of mass m and the value of g. Value of g is nothing but approximately at an average it is taken as 9.8 meter per second square. In some cases it is approximated to 9.8, which is nearly taken as 10 meter per second square. So you can calculate your weight according to this formula, as we have discussed already. There is another formula for the weight of an object, because by nature weight is nothing but the force of earth on any object towards its own center, right? So that we can also calculate with the Newton's law of gravitation, which is given by this formula, right? So weight of any object, it is given by the gravitational force between the object and the earth, which is given by this formula, capital G, which is the universal gravitational constant. Its value is fixed for every kind of calculation where it is involved, into capital M, it is nothing but the mass of the earth, and small m, again it is the mass of that object of which we are calculating the weight, and R, it is the radius of the earth, because we are taking this object to be lying over the surface of the earth. So in situation, the distance between that object of which the weight is being calculated, and the earth, it is equal to radius of the earth. Or even if object is very close to the surface, so close that its height above the surface of the earth can be ignored, or it is very small in comparison to the radius of the earth, even then we make use of this value of representation or radius. So this is about the mass and weight and the difference between the two. So for weight we have two different formulas. However, making use of this formula, it is quite easy. You can calculate the weight using this formula. It will come out to be of same value. Okay. Next thing we are interested here is in the free fall. So what is free fall of an object? So when an object falls freely from a certain height, in that case the object moves only under the effect of gravitational force alone, right? There is no other force other than the gravitational force acting on the object. Only the gravitational force is acting during the fall of the object. So that motion of the object in vertically downward or upward direction, it is called as the free fall of the object, right? So in this case, some certain object, it is dropped from certain height, that means we are giving it zero initial velocity. So whenever object is given some initial velocity, or we can say it is dropped from a certain height from the initial zero initial velocity, it is said to be moving only under the effect of gravitational force, and hence in such a way object is said to be falling freely. So this is what we understand from the free fall. Because in the free fall, freely falling object, it is only the gravitational force which is acting on the object alone, right? So the object is facing the acceleration only due to this gravitational force, and we already know the direction of this acceleration, it is nothing but the along the direction of the force which is causing that acceleration. So that means the only acceleration in this case in the object which is falling freely, it is the acceleration due to gravity, which is represented by small g as again here. So whenever this situation happens, either we are throwing object upward or object is falling freely, or we can say it is being dropped from a certain height. Both situations are identical. Only thing is that the value of g in the acceleration, it just changes, right? So how do we take the value of g in different situations? Let us take the first case. If object falls freely, means the object is released, or we can say dropped from a certain height, then the object moves only under the effect of gravitational force. In that case, the acceleration due to that gravitational force, means acceleration due to gravity, it is substituted positive. Its value, whatever it is, 9.8 or 10, it is taken as positive in the formula, right? Whereas in other situation, if an object is moving in upward direction, means if object falls, is thrown, not falls, but thrown up. Of course, we are throwing it by giving it some initial velocity only at the lowermost point, and then it moves only under the effect of gravitational force in upward direction to a certain height and then just come back down. So what is the situation? If an object is thrown up only under the effect of gravitational force, there is no other force, then after throwing it, then the value of g in calculation or in formulas is taken as negative, because in that case the motion of the object is in upward direction, which is opposite to the gravitational force, which is in downward direction. So whenever object is thrown up, it moves up against the direction of the gravitational force. The direction of gravitational force is in downward direction. So that's why the value of g, it is taken as negative in this situation whenever an object is thrown up. Whereas in earlier case, the object moves in vertically downward direction, which is the same direction of the gravitational force, and hence the acceleration due to gravity. So therefore g is taken as positive. So this is the way in which we substitute the value of g, small g, acceleration due to gravity. And this situation of either throwing an object vertically upward or an object which is falling freely, this situation is very similar to the straight line motion along the straight line with a uniform, or we can say constant acceleration, which is the acceleration due to gravity. So here we can also write the equations of motion in these cases. So here the three equations of motion, they get this form. The first equation, it is the v is equal to u plus gt. V is the final velocity and u is the initial velocity from which the object is thrown up or released from a certain height. If an object is released or dropped from a certain height, the value of u is 0, right? And after time t, when it falls, its velocity becomes v, which is calculated by using this formula, right? So u becomes 0 whenever an object is released from a certain height or dropped from a certain height, because its initial velocity is 0. It was not moving initially, right? Okay. Whereas in other case, whenever object is thrown up, it is thrown with some initial velocity. It has some initial velocity, and after going some certain height, it just stops and then just starts falling back. So at highest point to which it can go, its velocity, it becomes 0. So which is the converse situation. So this is the first equation of motion. Remember, in all these three equations of the motion, as in first equation of motion, we are substituting the value of acceleration to be g, because it is the case of acceleration due to gravity, a freely falling object or an object which is thrown vertically upward. Similarly, the second equation, it is given by s is equal to ut plus half gt square. Here again acceleration is replaced by the acceleration due to gravity, because it is only the acceleration, uniform acceleration, which is working here. Here the displacement, because the situation is telling that it is something about height, so we can replace the symbol of displacement from s to h, or we can also keep it same. It does not change the meaning of the meaning and value of the equations. Similarly, third equation of motion, 2g into s means h, it is equal to v square minus u square. Here g, acceleration due to gravity, it is again taken as g, right? So this is about equations of motion in case of a freely falling object or an object which is thrown vertically upward by giving it some initial velocity. So we make use of these three equations of motion in different cases to find out the required values in the questions. We will solve such type of questions in the next class. Till then, thank you.